An object in equilibrium has three forces exerted on it. A 33 Newton force acts at 90 degrees from the x-axis. So,
What's equilibrium?
equilibrium.
Yeah, you didn't even say it.
Equilibrium's when it's stationary. Nothing's moving.
It's equal in all directions.
All right, so I got one force. First force is at 33 newtons at 90 degrees. So right here on the y-axis, this is 33 newtons. Then a 44 Newton force acts at 60 degrees from the x-axis. So 60 degrees, I'm going to guess it's about right in here somewhere, who knows. They're at 60 degrees right there. And that is a 44 Newton, 44 Newton force. So 44 newtons. And both angles are measured counterclockwise from the positive x-axis, which we did. What are the magnitude and the direction of the third force? So there's some third force that's canceling this thing out. I'm going to tell you, probably going to be sitting somewhere right here. There's that good English I got coming out again. I'll take it out. All right.
That's what they meant with a third force.
Okay. The problem we have is right here with this force that's in blue. The reason that's the problem is we have to have x and y components. We can't just do it as it sits. So we're going to have to go and use our good buddy trig to fix this thing right up. So what we got is a triangle.
What if me and Trig don't talk?
That's not good.
Can we use our good buddy Brooke to do this for us?
No.
Yeah, I was like,
All right. So it's 60 degrees, and this is what we got. We know the hypotenuse is 44 newtons. So now we need to fill in this force, x component, and force of the y component. Going back, what happened again? Guys, look at your triangle. I know you guys are like top of your class, and y'all knocked trig out. And y'all probably all got A's. That's awesome. But don't jump. Actually apply the knowledge you've learned. Some of y'all looked at this angle here and you messed your trig functions up on your quiz, and that's what cost you. So, let's start. I'm going to do sine of 60 degrees is equal to force of the y component divided by 44 newtons. So the force of the y component is equal to 44 newtons times the sine of 60 degrees. Make sure your calculator is in degrees and not radians. Okay. 44 times sine of 60 is equal to 38.1051 newtons. 38.1051 newtons. Bad Newton. There we go. Alright, then we'll do the cosine. 60 degrees equals force of the x component divided by 44 newtons. Force of the x component is equal to 44 newtons times the cosine 60 degrees. So equal 22 newtons. So this is equal to 22 newtons.
Me and Travis was doing the 30, 60, 90 triangle.
There you go.
1 square root We knew one of them were gonna be 22.
Look at that, using that trig knowledge, and y'all look, so, when am I ever gonna use this in my life?
No, I never said
So if
that.
I'm gonna use this,
Every day.
I'm not going to.
Every day until you graduate.
Okay. So here's what I got now. I have these two legs of this triangle. So I now know this is 22 newtons. And I know that this force here is 38.1051 newtons. Now this is what I can do. I can add up these x and y components. So I can end up with, do it in blue. So, force of the y components. This is the net force. This is all those forces in the y direction being added together. Equals 71.1051 newtons. Everybody see where I got that from? I just added this 33 newtons with this 38.1051 newtons.
So that's everything in the Y direction.
That's everything in the y direction, because now I broke this vector up, so really it doesn't even matter to us now. This blue don't,
Why not?
because we broke it up into its components. All right, force in the x direction. Force in the x direction is 22 newtons.
Man. I didn't know if I could get that.
That's difficult. I believe in you. All right.
Wait, so that horse right there is. Wait, what? The
So-
green one.
What about?
What's it doing?
I just said that's where it probably said.
Problem.
Okay, that was my guess.
So
That's good, yeah.
technically, we don't know.
I have a better idea and I can solve for it. The reason I can solve for it is because right here, what has to happen? These two right here are the net force. Okay, it's the net, it's a component of the net force going in this first quadrant. What must this force be so that we can have this at equilibrium? In other words, it has to cancel out.
So it's gonna be the same?
This will be the same? So this shouldn't be here, it should be over here.
Oh,
You gotta use your F and Y, your Y and X components to make a new triangle, right?
Make a new triangle, but there's something special about it. I gotta make my new triangle.
It has 3 sides.
Come on.
go with negative.
What is the normal force and the force of gravity? What do we always say? They are equal.
Something magnitude opposite direction.
Equal in magnitude, opposite direction. So they must be equal in magnitude. So for my new triangle, force in the x component. Did you say it? When?
Like 3 times.
I thought I said,
Never heard you.
I said they're just gonna be negative.
I said they're
That's
gonna be
not the
same.
correct way to say it.
But it's the same thing.
I said they're gonna be the same, Mr. Hall.
That's right.
How crazy.
But they're not. Because look, force of the x component. The magnitude's the same. It absolutely is 22 newton, but it's got to be negative. The force of the y. Force of the y component has to be negative.
Because quadrant 3, X is negative, and so is Y.
Also,
How about
it's
that?
like calculus.
All right.
Your hippopotamus is still gonna be the same, Mr. Hall. Wait, no. No, it's not, Mr. Hall. Your hippopotamus is not gonna be the same.
How did you just assume that was right there?
He just wanted it to be, so it was.
This is what I knew. This is why I knew it being quadrant 3. What's all this in? It's in quadrant 1. So everything has to be opposite of it. It has to be equal magnitude but opposite direction. So it's heading in quadrant
Because
one.
it says equilibrium, right?
Exactly.
Okay.
Alright. So here's my new Higma-booger I got going on here. Okay. Here we go.
What?
Higma-booger. So to the left, x-axis, 22 newtons. And I'm gonna go straight down. And straight down is 71.51 newtons. Throw me off. We'll use purple again.
Because it's important.
Because purple stuff is important.
Like the Hulk, the purple pants.
That's right. Alright, so there's my hypotenuse. This is the thing.
I would be cool.
I want to be cool.
I gotta find that angle, but that's not the angle I want.
You're right.
I want to
Okay.
assume that's the right angle, right?
Buddy, that was 60 degrees. Or it
You
should
want the
be.
whole angle.
Oh,
This
okay,
here.
you want the whole
Add
shebang.
180 to it, boys.
Look at you. Lord, that's what we're gonna do. There you go, right there. There's your right angle.
He said he give a booger. He said, I have orange.
There's that little Higma-booger there. Alright, so I gotta find.
Your 71 should be negative.
Both of them. Well,
It's a
you would
triangle.
technically
It's still
know,
negative.
but you would know that it's negative.
There you
Right?
go.
Okay, there you go, because they're heading in the negative direction, but I guess I gotta label them as negative.
You have to.
Okay. Alright, so here it is. I got the force 3.
We did
Okay, this is the thing.
That's the answer.
This hypotenuse is my third force. I'm going to label it as force 3. So to find force 3, I'm just going to go on a jump. It's equal to the square root of negative 22 newtons, because it matters. And that's in the negative direction. Plus a negative 71.1051 newtons squared. That's the square root of all that. All that is Pythagorean theorem. That's all I did there. That's the only thing I jumped.
Wait,
Alright?
are you who did this, Jazz?
Where is it?
6,429.196.
So still got the square root.
Yep.
What's in it?
6429.196.
There it is.
Newton squared.
Jill, that's not what I got.
14
But then again, I just went ahead and.
You just jump. Yeah, you didn't square it.
And then
No,
if you
that's
square
not what I
it, it would be 80.188.
I got ahead. I got 18. I got
Oh my Lord.
18.449.
Give up a fly.
So know what you got?
No.
Um,
I got 586,312.
I'm done.
me and
I'm done.
me and
I got doing
Chloe
the
got the
7
same thing.
flat.
I got the same thing.
74. Can we just come up here and show you what we did?
Yeah.
I'm typing in my calculator.
Go right
You
on
gotta
the
balance
board.
math.
See? Mr. Hall, what's wrong? Oh my goodness, Liam's in the video.
You know that I can't get a hook with that.
This calculator's
74.4307. Know what y'all got?
Yeah.
There we go. Okay, so the magnitude of force 3 is 74.4307 newtons. Alright. There's my first part. Now I gotta find this little angle here. This is what I'm gonna do to find the angle. I'm doing a different color first. Find tan. I believe that's gamma. Is equal to tan. Opposite, so it's 71.1051 newtons divided by 22 newtons. So gamma will be equal to the inverse tan of 71.1051 newtons. You paying attention?
You changed the language on my calculator.
Set it back.
No, it's not.
Here you go.
I reset the RAM, it's still not back.
This is
Percent.
why we can't have nice things.
You got that right.
Wow, Joe, because you're so sophisticated.
Equals 72.8079 degrees. That's not the final answer for the angle.
Hold up a second, just let me write.
Oh, now you're paying
Yeah,
attention. Go ahead.
Mr. Hall, I have been writing this down.
That's improvement.
You can work
I did
and
it
have fun at the
different,
same
but I
time.
think I might have the same answer, so I'm just gonna see.
What'd you get different?
My triangle's like the other way.
Oh.
All right.
I just subtracted what I got from 52.
Oh, man.
Find theta.
What's the angle?
180 degrees plus angle gamma, which is equal to 180 degrees plus 72.8079 degrees, 252.
And that was the same answer.
8079 degrees. So, final answer. Write it in green.
Is it not important?
Huh?
Is it not important?
No, it is, but green means good.
No,
Go.
it doesn't.
And purple means
Very important.
very important.
Purple means hard.
Purple.
All right, so the third force. The magnitude of the third force is 74.4307 newtons, and it is at an angle of 252.8079 degrees.
This makes me never want to go into anything with.
Yeah. Me too.
This is the easy physics.
Can we just do another static problem? I hate, like, these are easy.
No, it's not.
Like, I don't mean to say
Okay,
that,
yeah,
but
this
like,
is so
those
easy.
are, they're not easy, but
Okay,
I
okay,
just don't want to say it's static.
okay. All right, hold on. I'll address that in a minute.
Calm down.
Any questions here?
What if I did my triangle? Okay, I got the same answer as you did, but I did my triangle a different way, and I just subtracted what I got from 270, and I still got 250.
Totally fine.
Okay.
Like,
Like I put it like.
I'm gonna guess what you did is you actually solved for the net force here, and you knew it was gonna be equal in magnitude, but then you knew it had to be over in this quadrant, so you took 270, which would be here, and subtracted it in. You can do
I
it
just
that
drew
way.
my triangle different.
You can do that way.
That way sounds so much easier.
Can we add a tribute to
Like 10 times easier the way that just, can we do it that
Hey,
way?
hey, you absolutely. As long as you get the right answer, but
I
guess
don't know how
what?
she did it that
That's
way.
still not the way I did it.
All right,
I
this
just
is
drew
a-
my triangle different.
I did some of these different ways by myself, and they're all wrong.
All right, all she's done is instead of this being her triangle, she did this as her triangle.
And then they would
And
have,
she did this angle here.
And then I did subtracted 270.
It's subtracting 270. It'll still work because you're still going to get the same resultant vector. You're still going to get force 3, but then she's got to subtract from 270 instead of adding 180. You literally, it's the same amount of work.
Yeah, I didn't know that.